Okay, today we're going to be talking about using factoring to solve polynomial equations. So remember, when you hear that word solve, okay, so they want you to solve this polynomial equation, essentially what they're asking for is they want to know where it's crossing the x-axis. Or, in other words, they want you to find the zeros or the roots of the polynomial. Okay, so for example, if we have the following polynomial, let's write this out. We can have 3x to the fifth and then plus 18x to the fourth and then plus 27x to the third. And now just recall they want us to solve this, so they want to find the roots of the zeros, and the roots and the zeros are where it's crossing the x-axis. Okay, so whenever this polynomial crosses the x, the y will always be 0. Okay, hence we set this equal to 0. Okay, we set the y equal to 0. And that will help us find the roots of this polynomial. Alright, so in order to do this, we're going to use factoring to find these zeros, or these roots. Alright, so the first thing we want to do, we have 3 terms here. Let's see if we can pull out a greatest common factor between the 3 terms. And it looks like they all have a 3 in common, right? And it also looks like I can pull out an x cubed, right? So why don't I go ahead and do that? So I'm going to have 3x cubed, right? And on the inside here, I'll have x squared plus 6x and then plus 9. This is all equal to 0. And I'm just going to take this a little bit further. This x cubed here, right? We could just kind of expand that out. So we'll have 3, and then we'll have x times x times x. Okay, it's the same thing. And then I'm just going to rewrite this here. We have x cubed plus 6x plus 9, all equal to 0. Alright? What I want to do here now is I want to go ahead and try to factor this, right? We can factor this using the AC method. This is a quadratic, right? Remember, a quadratic, so the equation of a quadratic, let me write this in another marker here, is going to be ax squared plus bx plus c. And if we're given a quadratic, we can use the AC method for factoring here. Alright, so why don't we go ahead and use the AC method. Again, that's a times c here. So just looking at this part right here, why don't we bring this down and work on it. So we'll have x squared plus 6x plus 9. So if I do a times c here, I get 9. Right, 1 times 9. And then you say to yourself, what two numbers when I multiply are going to be 9, okay, but add up to 6. Well, that's going to be 3 and 3. So we can rewrite this as x plus 3 and x plus 3. Okay, and again, I can put it right into factored form because notice that my a value here is equal to 1. Okay, if my a value was not equal to 1, I would have to take this a step further, okay, and do factoring by grouping. I would have to rewrite the quadratic out and group it. Okay, but in this case, the a value is 1. We can put it right in the factored form. Okay, so knowing all of this now, I know that this whole part right here is this. So why don't I go ahead and replace this now with what we have. So we have x plus 3 and x plus 3. Alright, I'm going to erase this. Now we're pretty much done. We just have to solve now for x. So when you do this, you simply just take each of your factors and set them equal to 0. So you're going to have multiple answers here. So again, this would be considered a factor, this would be considered a factor, this, and this, okay? So if we take them now, I'm going to go from left to right. If I do 3, starting with 3, equal to 0, Well, that doesn't tell me anything. That's not going to help me solve this because there's no variable involved. So this is just, we don't need that, okay? Let's go on to the next one, x equals 0. Okay, so that's one of my answers, x equals 0. The next one, x equals 0. It's another one of my answers. Next one, x equals 0. Okay, let's go into this one, x plus 3 equal to 0. Well, we know that's going to be x equal to negative 3. Next one, same thing, x plus 3 equal to 0. That will be x equal to negative 3. So when we look at this, we essentially only have two answers. We have negative 3 and 0. However, they're occurring multiple times. And when you have that happening, when you have an answer occurring multiple times and you're solving for a polynomial, that's going to be called a multiplicity. And we haven't got into this, we will in the future. But for this example here, if you wanted to write out your answer, you would say, okay, your answer would be 0 with a multiplicity of 3, because it occurred 3 times. So you would say 0 with, I'm going to abbreviate here, with multiplicity of, and we said 3. Okay, and then we also had negative 3 with multiplicity of 2. Yep, 2. Okay, so this would be your final answer here. So we would have 0 with a multiplicity of 3 and negative 3 with a multiplicity of 2. Alright, so we just solved that polynomial. Alright, let's try another example here. So here we have x to the 4th power minus 20 x squared plus 64. Again, they're asking us to solve here, meaning they want the roots or the zeros, so we know that we need to set this equal to 0 because whenever this crosses the x-axis, the y will always be 0. All right? Well, if we look at this, right, we have a degree of 4 here. All right? So how can we go about factoring this? We can't use the AC method because that's only for quadratics, right? And again, the equation of a quadratic is ax squared plus bx plus c. Well, in this problem, we can use a little trick here. We can rewrite this as a quadratic, okay, allowing us to use the AC method. All right, so what I want you to think about here, notice I have x to the 4th, x squared. I'm just going to give x squared a value here. All right, so follow along. I'm going to say that x squared equals u. Okay? X squared equals u. I'm going to go ahead and plug this in now. So if I do this, so x squared equals u, I will have here, well, here I'm going to write u, right, and then I'll have 2, right, minus 20 u plus 64 equal to 0. And let's just go ahead and finish this off. So we'll have u squared minus 20u plus 64 all equal to 0. Well, if you see it now, this is a quadratic, right? We just manipulated this into a quadratic. Alright, so let's use the AC method now to factor this. Okay, so using the AC method here, we do 1 times 64, right? Which is just going to be 64. And then we say to ourselves, well, what two numbers, when we multiply here, are going to be 64, but add up to negative 20. Okay, and it looks like those two numbers are going to be negative 16 and negative 4. Okay? When I multiply the two, that will be positive 64. Okay? When I add the two, it will be negative 20. So let's go ahead and rewrite this now. And remember, my a value here is equal to 1, so I can put it right in the factored form. So for example, I'm going to have here u minus 16 and u minus 4. Okay, now at this point, go back to what we wrote up here. We said that x squared is equal to u. Well, let's now replace the u's. So now we have x squared minus 16, okay, and we have x squared minus 4. Right? And this is all going to be equal to 0. Alright, so let's go ahead and find our remaining zeros. Now, there's a couple ways you could do this. You could recognize that this is a difference of two squares, and we could rewrite this as x plus 4, x minus 4. Same thing here, difference of two squares, we could rewrite as x minus 2, x plus 2, this would all be equal to 0. Or you could literally just take these factors and set them each equal to 0 and solve. Right, you'll still get the same answer. Since I have it at this point, let's just keep going with it. So let me write this nice and big. Let me erase this work here. So what we have now is we said x squared minus 16, and then we have x squared minus 4, all equal to 0. And we said that we can use a difference of two squares here, or you can just take each of these factors and solve. It doesn't matter, you'll still get the same answer. I'm just going to expand this a little bit further. So we'll have x plus 4, x minus 4, and then here we'll have x plus 2 and x minus 2, all equal to 0. And now it's quite simple. You just take each of your factors, set them equal to 0, and solve. So again, this is 1, this is 1, that's 1, and that one. So if we go ahead and solve now, well, x, starting from left to right, well, x will equal negative 4. Same thing here, x minus 4 equal to 0. So the x equal to positive 4. Alright, x plus 2 equal to 0. Well, this will be x equal to negative 2. Alright, and then the last one, x minus 2 equal to 0 will be x equals positive 2. Alright, so we just solved here, we found the zeros, and your final answer here is going to be, let's write it in a different color, we'll have negative 4, 4, negative 2, and 2. Okay, so that right there is your final answer. Alright, so that is factoring to solve polynomial equations.